Welcome to
KidMath130.
KidMath130. We're studying polynomials right now, but I want to do our movie today about a little project you did yesterday. So every day you do a little report out of this book, Clifford Pickover's math book. Okay? And yesterday you talked about the pigeonhole principle. Do you remember that?
Yeah.
Okay. Can you tell me what it says, the pigeonhole principle?
Well, it says if you have M pigeonholes and N pigeons, then there's going to be at least one pigeonhole which has two or more pigeons in it.
Okay, well that's close. There has to be some special relationship between M and N, though, for that to be true.
Well, N has to be greater than M.
There you go. So, for example, if I have 3 holes and I have 4 birds that are in the holes, at least one of them has to have 2. So it's a pretty simple idea, right?
Yeah.
If I have more birds than if I have more pigeons than I have pigeonholes, at least one of the pigeonholes has to have more than one.
Yeah.
Right? Do more than 2 have to have more than one? Let's say I had 3 holes and 10 birds.
Yeah, then that. Well, actually, you can just put the extra ones in one hole.
That's right. So it's hard to say much more than this, but it has lots of pretty interesting ideas. And I wanted to show you one specifically that was mentioned in the book that's interesting, but a little bit complicated, but it shows a very cool, really cool idea. Okay? So say you have, they use a dollar bill, but I'll just say, like, let's say we have a 3-inch square. Okay?
Yep.
And we're going to color this with 2 colors. Every point is either brown or purple. Okay? Prove there are 2 points with the same color one inch apart. Okay, so we color, I draw a bunch of points in here that are brown, you draw a bunch of points that are purple. Okay, and we fill up the whole square.
With the points.
Okay, every point, that's important, every point is in the square is covered. Now we're not going to go all the way through that in the video.
Yeah.
Okay, and it says prove there are 2 points somewhere in the square that have the same color and are 1 inch apart.
So maybe like if I had these 2 points.
Yeah. But it's hard to find them. It's hard to say, well, maybe this point, maybe this point, maybe this point. But then this is where the pigeonhole principle comes into play, and it's a really clever idea. You take an equilateral triangle somewhere in the middle of the square. 1 inch by 1 inch by 1 inch. Okay, and we know that fits inside of this square because the square is 3 inches by 3 inches.
Yep.
Okay, so it comfortably fits inside. Okay, if this was a 1 inch square, maybe this wouldn't fit in. So, but at 3 inches, we've got plenty of room. Now I look at this point, and this point. Since this is an equilateral triangle whose sides are 1 inch, what can we say about these 3 points?
They're all 1 inch apart.
They're all 1 inch apart from each other. How many points are there?
There's 3.
How many colors are there?
2.
Okay, so what can we say about these 3 points?
They are 1 inch apart.
That's true, they are 1 inch apart, but what can we say about their colors? There's 3 points and 2 colors.
Well, you can either have 2 of them, you can have 1 of them be a different color, 2 of them, or all 3.
All 3 can be a different color?
Well, if all 3 are like purple,
Okay, if all 3 of these points are purple, we're done, right? Because
if one of them, but if just one of them is, then you got these 2 work.
okay,
If 2 of them, then the new pair works.
yeah. Now, how do I know that I have 2 that are the same color on my triangle here?
Because of the end points on the triangle.
right? But why? What principle is coming into
The
play?
pigeonhole principle.
How is the pigeonhole principle coming into play?
Because you have 3 points but only 2 colors.
Okay, what are the pigeons?
The pigeons are the points.
The pigeons are the points.
And the holes are the colors.
The holes are the colors. Okay, so here's the brown. And here's purple. Okay. Now I have to put 3 points inside these 2 buckets.
So,
Right.
So 2 of them's going to be in.
2 of them have to go in one of the buckets by the pigeonhole principle. So this triangle is going to have 2 points that are the same color. So it's a very clever application of the pigeonhole principle.
Yeah.
It's pretty neat, right?
Yeah.
And this sort of thing comes up a lot in counting. Interesting applications in geometry. So the pigeonhole principle is actually a really powerful concept in math. It's really cool that they talked about it in the book. All right, it's a good report you did yesterday, and that there's an explanation of their more complicated example.